Hi, I'm here with Mike at Rohde and Schwarz, and he's got a pretty cool EMI demonstration hooked up behind us. Mike, can you take us through this?
Sure. So what we're doing here is we're actually doing an EMI measurement using an oscilloscope, which is kind of out of the ordinary, I guess. The problem we're trying to solve is measurement of differential mode and common mode interference, conducted emissions in this case. So one of the problems is typically with EMI measurement equipment like receivers, you can have one channel and you can measure one spectrum. But when you're looking at differential, you either have to have some way of separating the common mode and differential waveforms, or we can actually monitor both sides of the power separately, so you can measure the plus and minus wire. And the nice thing about this oscilloscope is we have a really powerful spectrum analysis feature in here that allows us to set the resolution, bandwidth, span, and center frequency independently of the oscilloscope settings. So down on the bottom here, we have the actual time domain waveforms. We minimize them into small little displays there. And what we've done is we created two math waveforms. One is the difference between these two, and one is the sum of those two. And then there's a spectrum of each one. So this is the common mode spectrum, and this is the differential mode spectrum. And so we can actually see the difference between the two. So then we're designing our EMI filter for the power supply. We can optimize which components to use and how, so that we can reject the larger the interference. So typically you might have a comm mode problem. You can actually do some comm mode chokes and things like that to overcome.
What kind of scope bandwidth do you need to do this effectively?
Well, not much. I mean, we're looking here out to about 30 megahertz. So this is conducted emissions, so pretty much any bandwidth would work. This particular model is 6 gigahertz, but you can do this with a 1 gigahertz scope quite easily, really.
I'm here with Tom from Rohde and Schwarz. He's got a pretty interesting component testing demo set up behind us that he's going to take us through.
You know, a lot of times when engineers are working on power supplies or doing DC power conversion testing, and this was normally done in a VNA, and it's called the two-port shunt-through method because you are basically using 2 ports on a VNA and some really sophisticated math to determine what exactly was my impedance value. But Rohde and Schwarz enables this measurement now on an oscilloscope, which most designers have on their bench and they feel very comfortable with. When you're doing this kind of measurement, you're going to have inherent ground loop problems. You have a ground isolator that gives you a flat frequency response out to, say, 6 gigahertz. And you have an active splitter, which takes the generator off the back of our scope, and it applies a sine wave into the splitter, which is then split between channel 1 and through the DUT and into this isolator and into channel 4. So it basically plots the math over frequency to give you an impedance curve. In this case, we're looking at a 1 milliohm resistor, and you can see you're getting really this 1 milliohm measurement on until it starts to drift up. You can use this measurement method for component testing, or you can also measure a whole system by looking in at the output capacitor of the system to characterize the whole system to make sure it's stable and optimized. On a VNA, you'd be looking at the S21 measurement. When you're injecting an energy back into this one, then you're able to then see what is the actual resistance value as it changes. We're partnering with PicoTest on this demo. PicoTest, for doing actual component testing, enables you to use a browser. So you would use this browser to basically snap in, and then it has these probe heads with different spacing, so like a 402 or an 805. So if I'm looking at a server and I want to do multiple power rails, it gives me the impedance value that I'm looking for.
If our viewers want to learn more about this particular solution, where do they go?
Well, they can go to our website, www.rohde-schwarz.com, and we have a lot of links to application notes and videos.